Now we'll take a look at some examples to try to apply the sine and cosine ratios. For each of these problems, it says find the sine of f, sine of g, cosine of f, and the cosine of g. Write each answer as a fraction and as a decimal rounded to 4 decimal places. Okay, so here's what we're going to find first. The sine of angle f. Again, if you know SOHCAHTOA, and for these problems, you just really need to know SOHCAH instead of the TOA part. We're not asked to find the tangent of any of the angles here, but the sine of f. Sine is opposite over hypotenuse. Here's angle f. What's opposite of that is 12, and then the hypotenuse is 13. That's simplified. I'm going to go through, find each of the ratios in terms of fractions first, and then we could round each to 4 decimal places. Okay, so that's the sine of angle f, the sine of angle g. So here's angle G, still opposite over hypotenuse, but now what's opposite angle G is 5. The hypotenuse is 13. We need to find the cosine of angle F and then the cosine of angle G as well. The cosine of angle F, cosine is adjacent over hypotenuse. So angle F is right here. What's adjacent? That's not the hypotenuse, is 5. And then the hypotenuse is 13. The cosine of angle G, is the side adjacent to angle G, 12 over 13, which is the hypotenuse. So now we could just evaluate everything in terms of decimals. 12 divided by 13, it says round to 4 decimal places, so that's going to be about 0.9231. Notice we have the exact same fraction here, so that should also be about 0.9231. Both of these fractions are the same. It's actually not a coincidence, but 5 divided by 13 and then round that to the nearest 4 decimal places, about 0.3846. And if you didn't notice, these two angles right here, angle G and angle F, even though we didn't figure out, and in the next section we'll actually go through how to figure out the measure of the angle, but we didn't figure out the measure of each of these angles, G and F. Those are actually complementary. The cosine of the complement of the sine of a specific angle, they're the same. Same here. So on exercise or problem number 4, the sine of 9 degrees is the same as the cosine of the complement. The complement of 9 degrees is 81 degrees. 81 plus 9 is 90. Just says write each expression in terms of the cosine. Just to double check, here's what you can do. I'm on my calculator right now. As always, for anything that we're doing in chapter 9, even though for the Pythagorean theorem, it doesn't really matter because we're not dealing with angles, but anytime we're dealing with trig, you always want to make sure that your calculator is in degree mode. But if you take the sine of 9 degrees, that's about 0.1564. That should be the exact same thing as a cosine of 81 degrees. I'm just double checking that, and it is. So these two are equivalent. So then on number 5, the sine of 30 degrees should be the cosine of its complement. The complement of 30 degrees is 60 degrees. And if you don't believe me that that's correct, you can check that on your calculator. Therefore, the sine of 77 degrees should be the same as the cosine of, can you figure it out? You want to take the complement of 77 degrees, so that's 13 degrees. And then on these next examples, now I'm given the cosine of an acute angle. I want to rewrite that in terms of the sine. So the cosine of 15 degrees would be the same as the sine of, can you figure out the angle? Should be 75 degrees because that's the complement of 15 degrees. And since this is the kind of a different problem than the ones that we just went over, if you take the cosine of 15 degrees on your calculator, again, make sure your calculator is in degree mode. That's about 0.9659 to 4 decimal places. The sine of 75 degrees should be the same as that. And it is. Again, you don't believe me, I did that on my calculator. So real quick, maybe pause the video for a minute, see if you can figure out problems 8 and 9. If you came up with, for problem 8, the cosine of 83 degrees is the same as sine of 7 degrees, that would be correct. 7 and 83, those are complements. And then number 9, the cosine of 45 degrees should be the same as the sine of 45 degrees. Those are complements of each other. Okay. But now going to the triangles, okay, on number 10, you want to find the values of x and y. It says round your answers to the nearest tenth. So let's just say, even though it doesn't really matter what order you do things in, let's say you want to find x first. Okay, here's everything that you know. I'm going to ignore this side right now because that's an unknown. But you know the 16-degree angle. You know the hypotenuse is 9. So in relation to the 16-degree angle, you have to figure out where x is. X is opposite that. 9 is the hypotenuse. So it might be helpful if you label those opposite. This is the hypotenuse, because only one out of your 3 trig functions, we're talking about sine, cosine, and tangent, only one of your trig functions uses both opposite and hypotenuse, and that's the sine. So you have to use that trig function sine in order to find the value of x. You take the sine of 16 degrees. Again, you always take the sine, cosine, or tangent of an acute angle, and the sine of 16 degrees is defined as the side opposite. That's x over the hypotenuse, 9. And then to solve this for x, you can multiply each side by 9. You're going to need your calculator. X is 9 times the sine of 16 degrees. So again, you just use your calculator for that. Make sure you're in degree mode. Otherwise, you would get an incorrect answer. So x should be about, what does it say? What to round it to the nearest tenth? 2.5, because you get about 2.48. Now there's 2 ways that you can find the value of y. X is 2.5. One way that you can find the value of y is the Pythagorean theorem. 2.5 squared plus y squared is equal to 9 squared. Since we're talking about trig right now and our trig ratios, I'm going to use trig in order to find that, just for a little bit more practice with trigonometry. Okay. If you use what's given, 16 degrees, the 9 is still the hypotenuse, but y is adjacent to the 16-degree angle. And only one function out of the 3 uses both adjacent and hypotenuse. That's the cosine. It's the ca, C-A-H, of SOHCAHTOA. So the cosine of 16 degrees equals the side adjacent, that's y, over the hypotenuse, that's 9. And then to solve this for y, you can multiply each side by 9. So y equals 9 times the cosine of 16 degrees. You can evaluate that on your calculator. That's what I'm doing right now. 9 times the cosine of 16 degrees. Did I mention you have to make sure you're in degree mode? Yes, I did. Like 15 times. So if you're getting a wrong answer, you probably want to check your mode really quick on your calculator. But 9 times the cosine of 16 degrees, that's going to be about 8.7. You really should get the exact same thing if you used the Pythagorean theorem, but wanted a little bit more practice with trig.